Hello everyone, today we'll be solving 1189. One of my friends asked me to check this out. Okay, so maximum number of balloons. Given a text, you want to use the characters of the text to perform as many instances of the word balloon as possible. Okay, you can use each character in the text at most once, return the maximum number of instances that can be formed. Instances of the word balloon. Ballon. So here it's one. Okay, right. So for this, we can count the number of, we can hash the characters of balloon, then we return them. So, okay, so this is quite straightforward. It's a hash map problem. So balloon, so B appears once, A appears two times, no once, then L appears two times, O appears two times, and then N appears one. So, and then we have one loop which has the counter of all. So we have, and then we check the number of characters of the input text, and let's say L appears four times, and then B appears two times, and A appears three times. So we return whatever is the limiting factor. So here, if four is the four and two are the limiting factors, considering only these three alphabets. Because with B we can maximum create two balloons, and with L we can create four. Yeah. So even if let's say there were three O's, yeah, three A's, we can only create two balloons. So that's how we solve the problem. So let's get right into it. So today, since this is an easy problem, I won't be using counter. So let's just manually hash it. So HM1, so for character in balloon, or let's just have this. So we have 1B, 1. I mean, I don't have to do this manually, but then it's pretty simple. So 1A, and then L, we have one, two L's, LON. So O, two O's, and then one N. So this is the balloon stuff. And then we have the hash map of the text itself. So let's call it HM2 is equal to that. So for character in the given text, if character is already in HM2, so if C in HM2, we HM2 of C, we increment it by one. So let's say, let's assume O is already inside the hash map. So when we find another row, we increment the number of O's from 1 to 2. And if it's not there in HM2, we just add it to the hash map. So HM2 of C equal to 1. And this is the hash map. So now let's say minimum, the limit is equal to 0 initially. We can have 0 balloons in the beginning. Um, let's look at the constraint. So the text length is at least 1. Okay. So first of all, if if the length of HM2 is lesser than length of HM1. Okay, never mind. So first what we can do is, okay, yeah, this part. So for each of the alphabets in balloon. So for alphabets in balloon, which is basically HM1. Okay. So we uh let's say the limit is equal to infinity initially. So we have to decrease the limit. So limit is equal to the minimum of limit and the number of bees in HM2 divided by the number of bees in HM1. So that would be HM2 HM2 of C divided by HM1 HM1 of C. And then in the end we return the limit and factor. So let's try that out. Mm, Key error E. So for A and HM1. Okay. We need a condition. Okay, my audio stopped working. So we need to add one more condition here. If if this character is not in HM2, then we just return 0. So if A not in HM2, then we return 0. Yeah, fair enough. Yep. I think my audio stopped working in between. Key error X. What's wrong with this? Uh, so for A and HM1, first of all, it shouldn't even be a problem. It's HM. Yeah, that's the problem. HM1 of yeah, yeah. If A more than HM2, return 0. So yeah, this should be HM of A because I called it alphabet, not character. So let's just use this test case and check it out. Yeah, and that's my solution. Yep, thank you.